welcome to this session, this last session of the day. Thank you for bearing with us so long. I'd like to introduce a little project which is about deploying an AI model to the cloud, for example, AWS, using some open source software that we've put together. So I'm going to introduce you to this project. I'm just going to do a quick check kind of how many of you are actually logged in, and I can check how many stars on GitHub I have got after this session. I know I'm sitting at 33 stars to begin with, so we will be locking the door if that doesn't reach 50 by the end of this session. So this is a little framework that we did as a team, and I'm just going to introduce this project. As I said, it's about AI, it's about deploying models, it's about cloud engineering, it's about open source, but it's also very much about engineering and architectural design. So even if you're not in AI space, you might still take some hints about how to organize your structure. Would you mind someone closing the door if that's okay? So let me introduce myself. My name is Florenz Hollebrandse. I work with JPMorgan in Glasgow in a data analytics team, and our lawyers would want me to say that anything I say may be rubbish, and don't sue JPMorgan for it, but just come to me. I won't be giving you money back, so that's obviously not a thing you can do with open source. So that out of the way, let's get a start. Yeah, if you close the door, Chris, behind you, that would be great. Thank you. Chris, close the door, please. Thank you so much. So AI projects, they usually start with some kind of research phase. Like we have a business problem that we want to solve, and someone says, you know, you can have an algorithm for that that automatically does what you want to do. So that's where data scientist comes in, and on their PCs, they may kind of spend a couple of weeks and not talking to anyone and come up with this magic algorithm, right? They might have some training data. If you're lucky to have some validation data that they independently say, okay, this model really works, have some metrics to prove that, some metrics about accuracy, precision, recall, all that sort of things get thrown your way. And obviously, that model is something in software. There's probably some files that contain some of the model parameters, and they will send that to you maybe by email, maybe by instant messaging, and if you're lucky, they give you some instructions what to do with that. Now, if we're thinking about deploying models to production to actually do inference and integrate with other applications in a big enterprise, then we're suddenly talking about a lot of other concerns. We're talking about like testing, versioning. We might have CI/CD pipelines that we need to wire this up into. Probably talk about, is this going into a private cloud, in a public cloud? How do we integrate it with other applications, and do we need to monitor that? All sort of stuff that kind of engineers kind of love to talk to you about for a long time. So they're quite different aspects. And if you're new to the kind of machine learning space, then if you do a quick Google search, how to deploy an ML model, it's quite overwhelming experience that you get. Because every single self-respecting tech firm under the sun will have some sort of end-to-end workflow that they promise you, right? And Googling which one is the best, you will have another top 10 of top 10s of top 10s, right? So you will spend a long time. Now, I'm not going to solve that debate here. That's obviously a very kind of personal setting what platform you adopt. So, but let me take an example about AWS SageMaker. It's been around for a long time, so some people might be familiar with it. If you're not, it doesn't really matter. SageMaker is just another compute platform under the hood, but it's optimized and is specialized for doing machine learning compute. Has it environment for doing model training, and it has an environment for doing model inference. And we say model inference, we mean making predictions. It might be in a batch-wise prediction settings, where you ask the model for lots of answers at the same time, or it might be a real-time, one answer at a time. That's basically what SageMaker is. So let's actually go through a little bit of a flow of what inference with SageMaker looks like. And I'm just going to have this little diagram where we start with a client application. There's one application that we need to integrate with a model. That application needs to know, what does it take to give me an answer? I've got some input data. So We've got our cloud platform as a whole providing all sort of infrastructure, networking, everything. And inside that, we've got this SageMaker, the AI ML server. Now, SageMaker, it's not a thing as such, it's just a set of kind of patterns and tooling that we have available. So if you're looking at what that compute and actually under the hood is just a bunch of EC2 instances. So EC2 instances, your virtual machines that you have full control over. But inside an instance, we put a Docker service. So we deploy our model as a Docker. Now, one of the surprising things with SageMaker is that we have a one-to-one link between an EC2 instance and a Docker image. Like often you do multiple Docker images on an EC2 to maximize the compute available and share that across microservices. But with SageMaker, by design, we want one Docker image per EC2 instance. That gives us the full control over what kind of compute instance that is. If I have a TensorFlow model or a large language model, they require totally different resources. There might be a lot of memory, or there might be a compute-optimized instance that I need for my specific model. So I need to know what that looks like. Inside that Docker container, as most things on cloud-native kind of development, it's all HTTP APIs that we connect with. It's super easy to integrate it, but it doesn't mean we have to effectively have a web server running in our container image. Now, the good thing with AWS SageMaker is that you have got pre-built container images available. If you want to have a TensorFlow image or a PyTorch image, you have a container image that you can pick off the shelf. However, as an engineer, I'm going to be kind of thinking about what's in those pre-built images. How can I test that in my pipelines? Do I know for sure it's got the required dependencies exactly with the right versions inside that? So I'm kind of thinking, you know, can I not just build my Docker image myself? Then I'm fully in control. I'm already kind of doing Docker builds for other microservices. It should be fairly straightforward, shouldn't it? Anyone here thinking about vendor lock-in? Or is that something that we've forgotten about? You know, at JPMorgan 5 years ago, we did talk about it a lot. We've kind of stopped a little bit talking about it. Maybe Robert is the only one that still really worries about that. But, you know, he's worried about it. But all application teams are no, Robert, that's a past stage, right? We're doing AWS and some other hybrid approach. We've got on-prem, so we're still at. Now, so with SageMaker, you could make the same concern, like SageMaker looks like kind of nice and high level, but do I lock myself in? And I think it's useful to differentiate between technology lock-in and vendor lock-in. So what I mean with technology lock-in, say if you adopted DynamoDB in AWS. It's Amazon's own database implementation, a NoSQL, some key value store, super easy and super cheap to get started with, right? What's inside that? How is that interoperable with something else? Nobody knows, right? It's quick. That's pure technology lock-in. Lambda's function at the end of the day, right? A Python function is a Python function, but still there's quite a lot of assumptions about how do we integrate that with AWS. On the other hand, if we're talking about Docker images, then suddenly we've got quite a common piece of technology that we can move fairly easily. So doing SageMaker inference and building our own Docker containers, ideally we should be able to have something that we can take anywhere. So this is where you start hunting about, okay, how do we build our own Docker image? And on AWS there is admittedly open source library available for doing that. But that's like, as a Python developer, I kind of, you know, look at, we can do better than that, right? It feels a bit heavy and it feels a bit, you know, optimized for nothing. So how can we do better than that? So better really means how can we do this a little bit smarter, right? How can we kind of have something that we're proud of? And as I say, kind of ticks a lot of the boxes in terms of testing, in terms of abstraction, kind of taking the platform away out of the equation. So the building blocks, we really have to kind of start again from scratch, right? What does it take? What needs to be in that Docker image? So at the bottom half, we've got this model. That's obviously something we need to load in memory, and we've got our client application. So loading the model is one concern. Once we get the HTTP request coming in, we'll have to deserialize that input. So there could be JSON bytes. Typically, it will be something like JSON, and we might need to deserialize that as a, say, NumPy array or a Python dictionary. That depends totally on your algorithm, right? And SageMaker can do any algorithm. That doesn't really matter. Now, once I've got the inputs deserialized, I can pass them to the model that I've just loaded, and guess what? You serialize that back as some output, send it back over the wire to the client. Now, how many boxes do we have at the bottom half? 4. So there's really 4 things that I need to define, of which 2 of these things are boring, deserialize and serialize. So, I should really, as a data scientist wanting to deploy my models, a bit more trivial, a bit like Lambda, I should just need to define 2 things. Now, that's exactly what this package did. So this is the package that you've loaded from that QR code. So you can follow that documentation online, but I'm going to give you a quick run through those steps. So we've got 4 hooks that we call it, corresponding to those 4 boxes that we need to implement in Python. The first one is almost the most difficult one, I guess. It's like loading your models. So there's actual code on the screen. You probably at the back can't see that. I do apologize that I can't zoom it. It's like a screenshot. But it has got like a model function hook. Does this thing work? Here we've got a model function hook decorated with some plugin hook, and I'll come back to that. And a model function is just something we'll say, at startup, our service will need to load this model. In this toy example, I've made it the shipping forecast, which is a classic kind of weather forecast at sea in the UK around the coastal waters, and it says, for a given location, give me the weather, say tomorrow. Yeah. Here I'm just returning another function, but you could import TensorFlow towards anything like. It doesn't even have to be a standard technology or algorithm. You could just make up your own custom algorithm that smart people in your firm have made up, right? Now, this model directory, if we've got, say, a serialized TensorFlow model, what's this 8.5 something file with our parameters, for local testing, this could be a directory that you just have on your desk. You could, as part of your automated pipeline, just generate a model in memory and put it on a temporary disk location. If we're going to deploy this to SageMaker, the SageMaker platform takes that from S3 and puts that in that container for you to load. So this is where I'm saying, like, containers are quite universal. This kind of proves I can do this locally. I can start it up as a local Docker image. I can do this on AWS. I can do this probably in Azure, right? There's nothing really special about it. It's just a single Python function. So putting that aside, so let's look at the input function I said as one of the boring ones. Most of the time that will be something like a JSON deserialize. Go. Again, it just takes the input that comes over the wire, and you're returning a data type that your model loads. So here I'm just taking the location key and sending a single string, but in reality it probably would be some tuple of some input parameters, maybe a dictionary, maybe something else, depending on my algorithm. Then the interesting one, and it's actually surprisingly simple in this case, is to actually make predictions. So many algorithms, your model where you do .predict, pass over your input data. If it was TensorFlow, it might be a callable like you've got on the screen here. I could here do some pre-processing, post-processing, anything I wanted to do here. If you compare that, for example, with the standard offering in AWS, if you Google kind of how to do pre- and post-processing with SageMaker on AWS, anyone guess what the answer is? Has anyone done their AWS cloud certification for an architect? What's always the answer? No, I'm more thinking about just adding a lambda, right? adding a lambda. So everybody's encouraged to add lambdas left, right, and center, pre-processing, post-processing, and then you can use a standard image. Now that works quite well. Like kind of nothing wrong with it. If your volume high enough, you will see it in your bills. But otherwise, nobody cares. But the thing is, kind of often that logic belongs, in my opinion, to the model predict logic. If I separate it out into the lambda function, how do I know there's no drift between my model and my lambda function? How do I kind of quality assure that? There's a lot of concerns there. And be able to package that, just as simple as this, into my own model package is, my opinion, kind of something that gets you a lot further, a lot quicker. Output function, so again, JSON is serialize it back to some bytes. So let's talk about those decorators, inference server .plugin hook. So inference server, that's the library we're talking about, and just decorating that with this function signals. This is one of the plugin functions. This is one of the functions, one of the 4 building blocks, and inference server takes care of running that. If you're going to look at what that looks like when you deploy it, you don't need to do any other kind of scaffolding or wiring up. You pip install the package with those 4 functions in a Docker file. So at the bottom, the shipping forecast, that's our package that implements the hook. The 4 functions that I've just given you. On top of that, you've got your inference layer that sits in between that and the Unicorn web server above that. So the Unicorn web server, if you're familiar to it, then you know that's a WSGI Whiskey web server. This is a standard Python web server. You can replace it with any sort of web server. It doesn't get baked into this framework. You've got full control over how you want to optimize that for your runtime environment. Fully compliant. We don't even need to say that we're running the shipping forecast model because the 4 functions get picked up automatically. And then finally, what we have, we'll just run it just like that, this inference server, that's all. Now, I said those 2 input and output serialized, deserialized functions, they're quite boring. What you probably will find that if you settle in your application for some JSON serialization, you might be able to reuse those 2 functions that you define. You could actually define them in a separate package, in a separate piece of logic that you reuse across your project. And then you really get to the promised land of a data engineer or a data scientist just needs to define 2 functions to get a model up and running. Now, what drives this behind the scenes? It's maybe something you've heard about, but you probably haven't, but you probably have used it if you're in a Python ecosystem. So plugin, nothing by us, so we don't have any stakes in this. It's just a plugin system, quite a lightweight, that you can define your own applications using things like plugin hooks, steps that other developers can hook into, or even your own team. And this is something that PyTest is built on. So if you're using PyTest, kind of fixtures and other hooks that do test discovery is built on Pluggy. And the last point is really, really crucial, kind of those hooks, they take effect by simply installing the package. If I split my 4 functions across 2 packages, if I install them, that's perfectly all right. So the good thing is you can Google this. Not everything you do for banks is something that you can Google. So there's quite a lot of there's good documentation out there which gives you pretty much a run through as I've done here. You can read a bit of comparison with the SageMaker inference toolkit that Amazon has. It gives you almost the same walkthrough. And additionally, we'll have kind of a section on how do you test this, kind of how do you test those 4 functions. There's, for example, kind of a test that tests them all in sequence. So it basically confirms you've defined all of them and you've given the correct annotation on that function. Very straightforward. So just some take-home messages. As I said, this is kind of much about engineering as it is about AI or ML. If you want to kind of adopt machine learning models in your projects, then kind of, pick a good platform, pick through the kind of promised land of end-to-end data pipelines, right from messy data to perfect results. It ain't gonna materialize, I'm gonna tell you that. So, you know, pick your vendor, pick your technology, just be aware of vendor lock-in, and if this is a library that you could use to separate your platform concern from your business logic, if there's one thing you can achieve, then you're kind of protecting yourself for a lot of future risk, future changes that might come your way. You're not afraid to take it elsewhere. If you're just interested in engineering a bit, then definitely kind of this kind of modular design, being able to kind of separate some concerns, being able to kind of separate your dependencies. Then Plucky is a really good framework to do this in Python. But there's obviously kind of multiple approaches, kind of, but this is something that gets you going very quickly. I think that's probably everything I wanted to cover, but there's probably more to it. So if you've got questions, please fire them. Otherwise, I will have a question for the crowd. So first question here.
Do you have any,
sorry, you go first, ma'am.
So do you have any insights to parallel platforms like a Databricks to SageMaker that you can other aspects?
Yeah, so I don't have first-hand experience, I have to say. Kind of, I know a little bit kind of what's happening. Kind of know, for example, Databricks is also supporting the ML flow patterns, and those are kind of a couple of levels of way, couple of styles of doing this thing. Kind of the lowest being function-based model loading. So yeah, but what we're seeing is that a lot of these are still kind of pretending that you can just have a single model somewhere that magically comes somewhere and you somehow upload it to the web, to the cloud, and then off you go. Like, kind of for us, the critical bit is some sort of solid pipeline that gets to do that. But, you know, kind of one of the questions kind of here is an ML flow container, if you actually look at it, has got a similar endpoint, right? So, you know, it doesn't really probably take much effort to adapt this to also fully support that sort of frameworks, right? I'm not familiar with what Azure is doing that. If someone says, I want to use exactly the same framework, maybe you could, or maybe you have something else that is built for Azure. Kind of there's not that much logic here that you're abstracting, but yeah. Yeah, so I'm a strong believer in kind of making sure that you test your code as much as possible and as production-like as possible before it goes anywhere. So there's test libraries there that comes with it that pretty much do that. What you get with SageMaker is that you've also got your health endpoint. Your health endpoint is also wired up into this. And it, for example, will confirm that the model was actually loadable. So for example, if I didn't have my model artifact on S3 in the location that I said, that health endpoint will detect that before you get anywhere. It doesn't, SageMaker will not even bring your container up healthily until that's satisfied. There's a couple of those techniques, yeah. Right, so configuration, you can think about, like, I've not shown you any configuration, right? As far as I'm concerned, there's no configuration. Now, you could, for example, think that the actual model artifact, the trained instance of your model, might go through quite a few iterations, and in lower environments, you might want to experiment with something like that, right? So SageMaker has got full support for kind of injecting the exact S3 location of your model. And that could well be different in different environments, depending on whether you deploy them from different AWS accounts or something like that. But if you had, say, logging settings or something, you would configure environment variables as part of your deployment in SageMaker. Yeah, so you could vary them as much as you liked or as little as you liked. SageMaker has also got support for kind of model variants that you can deploy, for example, a totally different container as sort of kind of A/B. As some sort of A/B testing. I see you're keen to leave this room, so can someone check whether we've got 50 stars on GitHub yet? Because some more questions over there. So yes, you, sir. I couldn't show you though, because that will be internal to JPMorgan. But to be honest, like the documentation that you have on the web, they pretty much kind of get you copy paste, and then you've got the thing running. Whether you're then going to deploy that, say, with Terraform or something else, kind of your preferred platform, you would kind of need to know what it takes to deploy to SageMaker. In SageMaker, a model consists of a model resource, an endpoint configuration, and an actual deployed endpoint, which is your actual HTTP endpoint with a DNS address and stuff like that. So you do need to know a little bit about that. So I'm certainly not promising a one-click deployment. Yeah. I think there was another question over there. Is that right? No? All keen to go? Sorry, question at the front.
It's not a question, just a statement. You're at 38 stars.
38. So, I mean, internal events, I only get 1 star after my talk. So, you know, I'm really grateful for the 5 stars we got out of this. No, thank you so much. If you've got any other questions, let's come to the front. But otherwise, I will give you 4 minutes back of your time. Thank you.